So this is a wheel, and this is a magnet. And if I stick the magnet on the wheel, now we have a generator rotor. Wind up some wire, stick it near the magnets, and now when we spin the rotor, we get a small charge. Chuck on an LED, and now we can visualize the generator in action. You can see here it's flashing as the magnets pass the coil, producing an alternating current. But let's get a little weird with it. What if I blow on it instead of spinning it with my hands? Well, it works, but I also don't fancy passing out just to make a little flashing light. So then, what if we can concentrate that air so that it's more efficient in transferring energy to the rotor? Now we can add a little spindle of lights that require higher voltages and current to run. But I'm still a little lightheaded. So let's try supplying air in another way. This is a pneumatic engine. And credit where it's due though, this borrows heavily from Green Gecko's single cylinder design. I just absolutely love his engines, they're pretty much the best in the business. Now this soda bottle will supply the air. It works very well by just simply shoving a T-junction through the cap. And this compressor will allow us to get about 48 psi before the pipe pops off. And there we have it, a little Lego pneumatic engine that can hopefully spin some magnets around in our generator. And you know what? I already have a little Lego generator from a previous video. This guy has some beefy magnets sandwiched between some copper coils, giving us a simple one-phase output. Let's see how it does with that LED spindle. Okay, well clearly output's enough for this. So now let's cram these two contraptions together. Here's our base, pop on the generator, chuck away the handle and get rid of this flywheel, and introduce them to each other. Feed it with some hosing to the tank, and set its starting position, and let's see. Okay, sorta. Now let's try adding a load. This bulb needs about 8 volts to run, and as soon as we add it, we immediately notice some resistance against the engine. Now it works a little better if I run it directly from the compressor, but it still struggles a bit. And then what if we add the spindle, which requires more current? Well, it stalls. Though I admit I did a crappy job modifying the pneumatic switch, so it is leaking a bit. What we can do though is reduce the gear ratio. It'll spin it slower, but it'll have more torque. So let's try this. Okay, now the engine can run a little faster as there's less mechanical resistance. The magnets are spinning a little slower, but more powerfully, with more torque. Let's try that again with the LED spindle.
Hey, there we go.
And now let's store some of that energy. This 1 farad capacitor is actually quite beefy. After passing the AC through a rectifier to turn it into DC, now this capacitor can store the charge, allowing these LEDs to stay lit for quite a while after the engine runs out of air. Now what voltage are we getting? This looks to be about 3.8ish volts at the high end, which is fine, but it's a little choppy. And I have an idea for a nice, smooth, variable air power generator. Getting back to our turbine concept, I want to smoothly transfer energy from compressed air to the rotor. This also allows us to build up speed and torque as we approach the working voltage, and resistance will only kick in once the load starts actually drawing power. So let's test the idea. Here's a gear, and if we blow on the teeth, it can build up some tremendous speed. I just love the sound it makes. Now we can attach a rotor directly to it, but the torque will be minuscule. So instead, we can gear it down so that the torque output is much greater. And using these scales, I want to see exactly where I need to blow to get the strongest torque. Now for obvious reasons, the edges work best here, and it seems we're getting about 6.5 grams using this gear. But let's try another shape for the turbine. This piece here is both smaller and has nice fins on it to catch air better. And indeed, it does seem to do a better job. Now we're getting over 9 grams, and because it's smaller, in theory, it should also spin much faster for the same amount of air. So let's give it a try using some air bottles and the gear reduction. Yeah, this seems to work quite well. But a thought occurs. This is only one set of turbine fins. What if we added a couple more and add 3 air inputs? Does this triple our output? Let's find out. This is my new 3-blade turbine. It's got a 15:1 gear reduction, allowing us to get some significant torque output when the blades are spun rapidly. And with a lot of trial and error, I've also optimized the angle at which the air is supplied to the blades. And speaking of air, this turbine has 3 inputs, which are supplied by these 3 valves, which means we can operate this on high, medium, and low power to give us higher speeds or longer run times, depending on what we need. So let's give this a whirl with the lift arm acting as a test rotor. Damn, I love that noise. But we need more air. Okay, let's try just one input. Yep, nothing crazy, but it works. Now some more bottles for the remaining 2 inputs. Fantastic, love that sound. Okay, let's make a generator. First we'll need some nice big magnets. Fortunately, if I squish hard enough, these fit tightly into this Lego frame. And when I say tight, I mean these are tight. They don't even budge when I throw them around. However, it is pretty damn heavy. So let me pop these onto the rotor and see if it can actually move it. Yeah, even with just one input, it seems to move okay. Then we'll need the stator to hold the wire coils. This time, I'm making this a 3-phase generator. So I'll need a shape that I can mount 3 coils onto. And speaking of coils, here's one I made earlier. I've wrapped it around a Lego axle so I can connect it easily to any frame. Now let's introduce the stator to the rotor, and we'll test out a single coil with some small LEDs. Interestingly, even just blowing these blades seems to be good enough. But let's try using a couple air bottles as input. Yeah, that works pretty well. At least we know that just a single input is useful in producing a small bit of light. And with some more tanks, this could probably run for quite a while. But how about a few more high-powered LEDs? These draw a lot more current and still work well with a single coil. And how much voltage are we generating with this single coil and single air input? Not even 3 volts, which is barely enough to power this LED voltmeter. So let's add another input. Okay, cool. Now we're up to just over 4 volts. Okay, let's go the whole hog with 3 inputs. Oh man, that's such a great sound. And we're getting almost 8 volts at its peak. But this is supposed to be a 3-phase generator. So let's use this needlessly oversized rectifier to combine all the inputs into a DC signal. Now all 3 coils will contribute to a nice smooth output, with 3 times the current output. By the way, if you'd like to see more of these LEGO experiments, please feel free to like or subscribe. Cheers! I'm expecting a voltage drop here, so let's see what we're working with now. Just over 5 volts. Now I guess we could just pretend this thing is a USB power supply. This